Okay, we're asked in this example to state the domain and the range of the square root function g of x is equal to the square root of 2x minus 5. We're going to do it two ways. So first of all, let's just do it graphically, visually, looking at the thing. The domain is how far the graph stretches from left to right. Okay, so this graph first comes into existence if we move in from the left. The first time the graph appears is here. Okay, so that which appears to be 2.5. Okay, and then so that's where it begins. So we're talking here. Oops, where have we lost it? We've lost everything. We're back. Okay, so for the domain, what you think about is, where does it begin? As you come in from the left, where does it begin? And it begins, it seems to be here at 2.5. And then you think, how far does it go to the right hand side? And if you look, if we move across here to the right, okay, the graph is still there. And when we run out of space, the graph is still going. Okay, this graph is still going across to the left in this direction. So it goes on forever. We're going to assume that it goes on forever. I guess we don't know that specifically, but we're going to assume that if the graph hasn't ended by the time we run out of space, that it goes on forever. And remember, going across over here to the right, that's actually infinity. So we're saying that this graph begins at 2.5, coming in from the left, it begins at 2.5 and it goes on to infinity. Okay. Now, 2.5, we're going to put square brackets on there because 2.5 is where the thing starts. Infinity isn't actually a number though, it just means that it goes on forever. So to indicate that it's infinity and that it's going on forever, we use parentheses here in this end. So 2.5, because we know it's a definite starting point, we use the square bracket, and the infinity we use the parentheses. Okay. Now range. Let's talk about range. Okay, let's talk about range here. And range is, where does it begin as you come up from the bottom? What height does the graph kick in at? And as you come up from the bottom, the graph doesn't start until you get to the side here, until you get to the axis. And remember, the height of the axis is 0. Okay, that's a height from 0. And as we keep going up, the graph keeps going up. Okay, the graph keeps going up, and it's still going up. This graph is still going up. Okay, it's still rising until eventually it runs out of space over here. But that's not the fault of the graph. That's just we've run out of space for drawing it. So for the range, it begins at 0. Okay, it begins here and at 0, and it keeps going forever and ever. So when something goes forever and ever, or at least again we're assuming it goes forever and ever, if it runs out of space, that's the assumption we make, that means it's going to infinity. And again, infinity takes round parentheses. So square bracket if we know exactly where it starts, which is at 0, parentheses because it's going up and up and up and up. So domain is left and right, from the left to the right, range is from the bottom to the top. Okay, so that's the graphical interpretation. Now let's look at an algebraic approach. Okay, so if we do this in terms of the domain algebraically, then what you say for the domain in this instance is that the expression under the square root sign, in other words 2x minus 5, has to be greater than or equal to 0. Okay, so for square root graphs, you find the domain by setting the expression under the square root sign greater than or equal to 0. Now let's solve that. We get x on its own, so 2x is greater than or equal to 5, and let's divide across by 2. X is greater than or equal to 5 over 2. So x is greater than or equal to 2.5. In other words, x is bigger than or equal to 2.5. In other words, x goes from 2.5. It's bigger than that. It goes up forever and ever. It can be as big as you want. Bigger than that. In other words, 2.5 to infinity. Same answer as we got up here. Okay? Same answer as we got up here. The range Okay, let's talk about the range algebraically. For the range algebraically, what you say is that the square root part of it, including the square root sign, has to be greater than or equal to 0. Okay? So the answer for a square root has to be greater than or equal to 0. So for the domain, we take the piece under the square root sign, but we throw away the square root sign itself. For the range, we need to keep the square root sign. And we say the square root of 2x minus 5 is greater than or equal to 0. But look up here. Square root of 2x minus 5 is just g of x. So this is just g of x. So you can say g of x is greater than or equal to 0. So the whole idea here is to get an expression that has the square root on one side and then replace the expression with g of x. So greater than or equal to 0 means you start at 0 and you go as high as you like. In other words, to infinity. Okay? Which is, again, the same as we have here. Okay? So there you have two ways. The domain graphically, and the domain algebraically, the range graphically, and the range algebraically. Okay?